Those of you who have a really strong idea of what your research design is, like you don't have to come in tomorrow. But for those of you who, are not really sure what you're doing, we'll get you figured out so that you can do well. Like I said, I noticed a big gradation, so that's not necessarily bad, right? And I graded you guys all well. Like I didn't mark you down for that, but I just noticed that some of you don't seem necessarily as prepared yet. So, which is totally cool. But that's my plan. So that's what I prepped for today. So, okay. Where did I put it? Was it on already? Oh, it must have been on already. I got an email saying not to get close to students, so every time I move forward, we're endangering you because we're from the community. Apparently the community is getting pretty bad. I'm not sure if you guys saw that. Did you? There's a big surge in Atchison, so be careful also if you go out in public. And I feel doubly wary just because my wife works in she's a theater teacher, so she's with a lot of people from the community. So if one of your professors is going to get you sick, it's probably going to be me. So stand, keep good social distance from me. It goes against my nature. I like being close to people. But okay. So the first thing, and I'm going to kind of just slide from one into the other. But we're going to talk about the elaboration model, and then we're going to talk about particularly regression. So we've talked about these terms already. So you have your independent variable, you have your dependent variable, right? And so essentially when we talk about correlation, right, is just testing whether there's a relationship between the independent variable and the dependent variable. All that's really clear now, right? We're all good on that? Okay. And what's the variable that's in the middle? Familiar with this? This is so what you want to do often when you run statistics is you're going to have a control or a test variable, which I'm going to denote as CB. Okay. So the elaboration model is, in essence, a way of thinking about correlation to determine whether something else is affecting it. So most of the time when people do statistical tests, they don't just test to see if there's a relationship, right, like we were talking about last week, but then they will control, right, for certain variables that might be affecting, right? So, if you're interested on the relationship between, social class, right, and political affiliations, right, whether people are Republican or Democrat, right, you may control for something that might affect that variable, right? Does race have an impact on this? Does region have an impact on this? Traditionally, what regions of the United States are poorer than others? People know this.
Big city.
What's that?
Big city.
Big cities are pretty disparate. There's big difference in, there's a lot of inequality in cities, right? So there's people who are very rich in cities. Richest people live in cities. So do some of the poorest people. What region of the United States is?
Like the southern region?
What's that?
Like a southern region?
Yeah, the South is pretty, and which part of the United States is generally politically conservative? The South, right? So like, is that an intervening variable? If you control for it, does the relationship still hold? Right? Those are the kind of questions that you're going to ask with a control variable. So essentially what the control variable lets you see is essentially gets you to copy what we were looking at for experiments, right? So if you think about experimental control, the whole idea is that you're getting rid of things that could get in the way, right? That would cause you to misunderstand the relationship between your independent variable and your dependent variable. Essentially what you do in an elaboration model for statistics is you falsely replicate that mathematically by controlling for intervening variables, right? Variables that could get in the way, right? Make sense? So this was, there's a couple ways of thinking about the results you get from this. Because what were the things that were important for understanding whether there's a relationship between these two things or the nature of that relationship? There's two things we talked about last week. Do you remember what they are? So one is whether that is statistically significant relationship, right? Whether it's just due to random chance or whether there's a pattern there. The other was whether it's positive or negative, right? What does it mean if you have a negative relationship? Just reiterate. What does a negative relationship mean? So on your statistical chart, you get a star, and there's a negative. What does that mean?
As one increases, it decreases.
Yeah, if it's got a negative, it means that as one increases, it decreases. If there's no negative, if it's a positive relationship, as one goes up, the other goes up. Right? So control variables will alter whether there's significance, but it also might alter the direction of the relationship. And so there's different ways in which you would talk about what the control variable is doing, but essentially it allows you to understand its relationship to the other two variables. And that's what the elaboration model is all about. Make sense so far? Okay. So there's a couple different variants of the evaluation model that our author provides us for us. One is Lazarfeld's distinction. Make sure I spell it right. Lazarfeld came up with this in the 1940s. Pretty much right when we get the ability to mathematically control, that's when they start doing this in sociology. So before that, there was no way of doing this, right? And actually, like a lot of so the statistics we use now, what's called linear regression. It's a newer system of statistical mathematics. There's ones that are older, but people don't really use them anymore. And it has this ability to control things, which comes from the 1940s, developed in the military and at the Columbia University. So Lazarfeld wants to talk about whether you have what he calls replication, explanation, interpretation, specification, yes. And so all those are just ways of referring to what can happen when you control for a variable. Clean this up a little. So what happens in replication is you control for the variable, right, and it stays the same. The same thing happens. So a good example would be, let's say let's say that there's a relationship between, I don't know, years of age and number of calories consumed. Right? So there's a negative relationship, right, between years of age and the number of calories consumed. Right? So what would that mean?
As you get older, you don't need as many calories.
Yeah, as you get older, you don't need as many calories, right? So old people eat less, right? And what do we want to control for? Let's say we control for, I don't know, social class. And does social class have an effect on it? Probably not, right? So basically what happens is it stays negative, it stays positive when you control for it. That's replication. What does replication mean about the control variable? What is the control variable doing?
No.
It's doing nothing, right? So it means that the control, our CV, right, is pretty much unimportant. Right? It has no effect on the relationship between them. Most of the time when you control, that's what happens. So, you know, a lot of studies, like especially like economics, loves to just throw a ton of control variables in there. So they might have an independent relationship and a independent variable, a dependent variable. They might have 20 or 30 control variables. Most of those will have no effect on their independent variable and their dependent variable. Sociology, we usually don't do that, mainly because it kind of hurts the mathematics of it a little and makes it less reliable. But we will, we usually handpick ones that we think might affect, right? Which means it's more likely to, but often you get replication, nothing happens. Okay, so let's go back to our relationship between social class and party affiliation. Right? So you could, you know, you could control for region, right? You're like, well, maybe the fact that there are more poor people down south means that there's more conservatives that are poor, right? That might be what's causing it. That variable might have a relationship. The relationship that we often talk about for that is has a antecedent relationship. An antecedent relationship would be when your control variable causes your independent variable. And your control variable causes your dependent variable. Right? So what that means is that there's a phantom relationship between the two that doesn't actually exist. Right? That's an antecedent variable when this happens, right? And this antecedent, in this case, right, we control for it. So we control for region, and that's our control variable. And what happens? Well, all of a sudden, our previous relationship disappears. There's no statistical significance, right? That is when you have explanation, right? Essentially, what that means is that in the elaboration model, what you found is you found that the relationship between our independent variable and our dependent variable is spurious, right? Spurious correlation means that some third outside thing caused it, right? Make sense? Any questions about it so far? So it's a complete opposite, right? If you want to think of it, replication, right? It stays the same. Explanation, it disappears. So let's see what we want to do for interpretation. Put a note on here. So for interpretation, it means that there's only a relationship. So initially you do your test, no relationship, right? But then you control for something, right? And then all of a sudden there is one, right? So for those of you who are in race and ethnicity class, right? We did this thing on gerrymandering recently. We read this article on gerrymandering. Do you guys know what gerrymandering is? I see a nod. Would you like to give an explanation, John? Be bold.
Isn't it where they stack the jury?
It's not. No, it doesn't have to do with juries. It has to do with voting. Yeah.
It's where they redraw like district lines, so like include some people or exclude others.
Yeah. So it's when essentially parties will redraw voting lines to exclude some people or include some. And we're looking in particular cities will basically do a form of gerrymandering when they grow. So cities can like basically take over things that surround them, right? Areas that aren't part of the city become a part of the city. And generally speaking, like they will do it in ways that exclude people of color to keep them from being a part of the city, right? So this is a very common gerrymandering thing. And in this study, it was looking at, with African Americans, it pretty much always happens. But with Hispanics, it doesn't often, right? So like when they have like, essentially like, you know, for being Hispanic, if a neighborhood is Hispanic, it doesn't have a, it doesn't seem to have a relationship with whether it's acquired by the city. So they're just likely to acquire it as not, right? Does it make sense? You guys kind of following the idea? So there's no relationship, but then they controlled for in the study whether the demographics of the city was changing. So cities that are becoming Hispanic, right? Cities with high increases in Hispanic populations, there is a negative correlation to being Hispanic and the neighborhood being Hispanic and it being acquired by the city. Which basically means that in places where people are paranoid about the number of Hispanics in their city, they do not want to annex neighborhoods that have Hispanics in them, right? That's an example of an interpretation, right? In an interpretation, you have no relationship, then you control, and then you get one, right? Make sense? So you guys seeing what the control variable does really changes how you have to interpret the relationship, right? It's not as simple as, and a lot of times we want to talk about as if the only thing we're interested in is replication, whether or not the relationships is like persist, but then there's all these other things that can happen when you control, and they're just as important for interpreting it. Okay, last one is specification. So actually, like in this exact same example, we started with a specification. So if we were just to say, if we were to start with the relationship of whether, right, there is a predominant minority relationship in a neighborhood, right, has a relationship to, right, its acquisition. This is true statistically overall, right? But if you control, and in this case you control by divvying up the populations, right, to different kinds of minorities, what you'll find is that is that some of them have a relationship and other ones don't. This is referred to as that's when you have specification. The controlling variable indicates to you which subgroup that you're studying is statistically significant. Right? In the same way we could talk about the relation, with the one that we started with, right? The relationship between social class and political affiliation. If we were to break this into region, you know, whether it's, you know, in the Northeast, Southeast, Midwest, Northwest, or Southwest, I think what you would find is, and this is just a complete guess, is that some of these would be statistically significant and some of them would not, right? Or which party people affiliated with would change. Poor people affiliated with would change depending on which region of the world you were in, right? In the Southeast, you're probably going to have a predominant number of poor people being conservative. So if we were to give this a conservative a 1 and liberal a 0, right? We may find relationships across all these, but what kind of relationships are going to be changing throughout, right? So like, it'll probably be a positive relationship in the Southeast, but it'll probably be a negative relationship in the Northeast, right? Where you have higher minority populations, or in the Southwest, right? You're probably going to have a positive relation. You're more likely to have a positive relationship maybe in the Northwest or Midwest, right? Where you have a lot of low poverty, and smaller minority populations. So yeah, so if you think about that, that's all specification. When you break things down by the different parts of the variable, and then you get different results. Will that make sense? Okay, cool. A somewhat simpler model than Lazarfeld's, which Lazarfeld initially doesn't talk about positive and negative, but I think they still work within this framework, is Rosenberg. And what Rosenberg wants to talk about instead is the difference between suppressor variables and distorter variables. So a suppressor variable is in essence when you start with, and think of these as just different taxonomies, right? So don't try to cross them, or you're going to get confused because they overlap. They're not the same. So with Rosenberg, what he is particularly interested in is that suppressor variables, right? What they do is they conceal relationships. They essentially keep you from seeing, right? So this is when you control, and then all of a sudden there is a relationship. He refers to those as suppressor variables. Distorter variables are things that change the nature of relationships. So a suppressor variable changes whether or not it is statistically significant. Distorters change whether or not it's positive or negative. Make sense? And so it's a little bit simpler dichotomy. I think it explains a little less personally, but it's a little simpler dichotomy. Okay, any questions on that? Are we all clear on these different relationships and how they work, getting a feel for statistical significance? Cool. The last thing in this chapter on the elaboration model that we should talk about is ex post facto hypotheses, which is a mistake that people make. And this is going to sound really weird. It is a little weird. Because like we have a tendency to think of data as like, you know, like if the data works out the same, then it's the same thing. As in like, if we run a correlation, regardless of the reason we run the correlation, it's equally scientific, the results, which according to most methodologists, this isn't true. So what a lot of people will do, which is considered unethical, and if you ever do this and get caught, you'll probably get kicked out of professional societies, is, although a lot of people do it, and actually like every year people get caught doing it and get kicked out, is basically they'll just go and they'll find a data set and they'll just run correlations until they find them, right? So they just run different relationships and then they'll explain it after the fact, right? They'll be like, well, my original hypothesis was, right, even though they didn't actually have a hypothesis, they were just running correlations until something popped up, right? And so, especially in an environment where publishing often has gotten more difficult, people's time constraints have gotten greater within academia, as in they have less time to do research and they have to do more of it. So, you know, for tenure, publishing requirements on average have gotten higher. It's harder to publish, right? And people also now are teaching often like 5 courses and they have to publish, right? So they have less time to do it. This is becoming more and more common. But there's a problem here because like the idea of a hypothesis, right, and this is kind of, is that I have for some reason, on the basis of previous research, I have a reason to believe that there's a relationship between something, right? So I start out with my hypothesis, right, because of, you know, previous research. Right? And then I test it. Small things that we, right? And then I get results. And those results will tell me whether my hypothesis was true or not. Right? Is this induction or deduction?
Deduction.
It's deduction. Right? You're moving from theory to observation. What is it if I just run a bunch of statistics on an existing data set and find numbers? What am I doing? I'm doing induction. So if I claim to be doing deduction when I'm doing induction, that is when I am doing an ex post facto hypothesis. In other words, I'm pawning something off as a test that is not a test, right? So like it's false deduction. And that's actually the problem with that. So it'd be one thing, I can technically do that, run a bunch of statistics and be like, okay, I was the first person to run statistics on this data set, and what I found was, right, all these various things, and this is how I'm going to explain it. If you present it that way, then you've done induction and you're essentially in theory construction. Nobody in statistics does this, for the most part. Usually when you're doing theory construction, we're talking qualitative, right? But nonetheless, like logically speaking, you could do that as a scientist and it would work. But if you present it as if you're hypothesis testing, you're not actually ever testing a hypothesis, right? You developed your hypothesis at the same moment you tested it, which means that it's not a test. Does it make sense? You guys get why that doesn't work? So it doesn't really seem to make sense because you would think if the statistics remained the same, right, it wouldn't matter. But really our intention towards the data is just as important as the data itself, right? Which sounds really backwards and weird and fuzzy to say, but that's actually how it works, right? And so if you think about it that way, right, like deduction is about testing. This is one half of science, right? To pawn it off as the other doesn't really work. Now, of course, you could, let's say, and this actually did you guys even catch the study that the chapter starts with? This is a study that Lazarus used to create his data originally, and we came up with the different categories to look at in the elaboration model. Did anybody catch what the study was? This is started at the very front of the chapter if you look through.
Is it like something with soldiers?
Yeah, it's something with soldiers. It's about, so the chapter starts with, here, I'll just go to it. It starts with, when you have ideas while you're speaking, it takes a second to find them. Okay. Yeah, so it's this Stouffer study of basically like military morale. Right? And they made a series of predictions he made a series of predictions that pretty much everybody always makes, right? That people just threw around in the military in the 1940s, which the three things that people always talked about morale is that promotion is good for morale. So if people are promoted regularly, morale will be high. The other thing is that African Americans should be stationed in the North, right? Because the South is prejudiced at that time, right? So people didn't want to be in segregation, right? Lastly, soldiers that were more educated were less happy. When Stouffer tested this, right? And keep in mind this is during the draft, right? So the idea is like you get a law degree and then they draft you and send you into the military. You're more likely to be disgruntled, right? Is the idea. When Stouffer did the study, which of these were true? Did anybody catch this? None of them, right? Which is the development of something in social psychology called relative deprivation theory, right? It's from this study where essentially he's like, the reason why is people only compare themselves to the people who are around them. So if Southerners are stationed down south, they compare themselves to if African Americans are stationed down south, they compare themselves to other African Americans that are stationed down south. They don't know African Americans, they're not in their immediate lives, right, that are stationed up north, so they don't compare themselves to them. Right? In the same way that like educated people generally don't know anybody who could skip the draft, right? Because generally at that time they were giving deferments to farmers and factory workers. So like my grandfather was a farmer and he deferred being in World War II for like 4 years. Still ended up having to go to World War II, but he deferred it for 4 years. So people who got drafted were more likely to be upset if they're from the working class because they knew people who got out of the draft, right? Relative to in their reference groups, right? There was that change, and also like he explained that like basically like which branch of the military you were in determined whether you liked promotions or not. It felt like the promotion system was fair. Ironically, in the military police, where no one gets promoted, people thought it was fair because they didn't know anybody who got promoted. But in ones that have high promotion rates, they're actually more dissatisfied with the military because they see people that they think of as worse than them getting promoted, right? So like the point is this, the point that I'm making is this. He is not making ex post facto hypotheses, but what he is doing is he's reacting to his findings, right? So his hypothesis is false, but then what he's doing is he's interpreting it. So if you run a statistic and then don't get the results you expect, then you provide an interpretation. But what you do when you've done that is you've actually moved from deduction, where essentially like what you found is that your deductive reasoning was false. But it's okay because you are actually presenting the real logic behind what you're doing. Make sense? I know it's a little abstract. let's talk about regression. So regression, like I said before, is basically the only statistics you ever see. Regression is the most important. Now, before regression, there was correlation. Anyone here in statistics learn what Pearson's R? Learn how to do Pearson's R? No? Pearson's R would be the older form of correlation. Right? And so Pearson's R can give you a correlation, but it cannot allow you to control. Right? So we've just seen how important control variables are for interpreting relationships, right? Pearson's R doesn't allow for the kind of control that you get in regression. So multiple, the most common you're going to see is multiple linear regression. That's the most common. And we're going to get into, there's some things that happen with, and we talked about these different types of data before, nominal, ordinal, interval. Do you remember that? So those have important ramifications for how you test things. And then take this as it's just sort of like, this is just a sample, right? In other words, like, if you go into grad school, I had an entire course just on forms of regression. I don't remember barely any of it because I don't do statistics, but I had an entire course where we went through all the different forms of regression and how they work and how you use them. But the most important one, the one you see the most, is multiple linear regression. So regression kind of works off of this idea that it compares the numbers you get, right, to what's called a line of best fit. So let's say for this one, we're going to do our independent variable. For this one, we're going to do our dependent variable. So like the line of best fit would be within the parameters of the numbers that you have possible. The best, essentially the best placement, the thing that would suggest that there's a perfect one-to-one correlation. Every time one goes up, one goes down, right? Or every time one goes up, one goes up. If it was like mathematically perfect, that would be referred to as the line of best fit. So where Pearson's R, or correlation hit, is basically based off of this, like seeing what one number does and what the other does, and mathematically seeing whether it's related. What regression does is it simply says, how close are my cases to the line of best fit? Right. So, and you'll see often included, you guys may see have seen this before in quantitative journal articles. Sometimes they'll literally put this, what I'm drawing right here is something called a scattergram. Or sometimes it's called a scatter plot. And so what you really want to see is kind of like this weird little cone shape. So if you have good regression, it's going to look like this. Basically. It's going to be this weird little graph with a bunch of dots. There's one of these graphs in the chapter, right? So this is basically when you know you have a good regression. Right? You may have some, and what the scatter plot is used for is you might have a statistically significant relationship, but there's some weirdnesses. And you can usually tell if it's caused by your data by the fact that it's not going to take on that shape. Right? It's going to instead, be like, or something like that. And you might have a statistically significant relationship, but there's not actually kind of, right, where they're actually building upon each other. Anyways, you can just visually do that with a scatter plot, but the number that regression produces you is usually what people are interested in. And that number will give you, right, whether there's a correlation, right? And those are the logical control figures. Make sense? Okay, lastly, I'm going to draw your attention to, or not quite lastly, I'm going to draw your attention to page 477. And what I want to say is, one, Abby's trying to get you to think about how you go about picking a test, right? I'm not going to ask you to say what statistical test you're going to use, because, like, to be honest, like, you're not going to use it, and not all of you have taken statistics yet, right? So it's going to be kind of a high expectation, right? But generally speaking, after you've collected your data, you have to run different types of correlations on them. You have to pick different types of tests on the basis of what kind of data you collected. So this is why earlier on when we were talking, before we talked about survey research, we were talking about having to know the difference between nominal, ordinal, and interval / ratio data. Do you guys remember this? What was nominal data? Let's review. Or we could give an example of nominal if you can think of an example and move backwards.
Like a gender?
Yeah, we talked about gender being nominal. Right? It's nominal because gender is generally just an expression of name, right? There's no ordering to it. Right? So, nominal variables, right? You have male, female, and maybe you have other, right? And that's your gender, right? Nominal means name, right? So nominal data is essentially when people say what they are. Another good example of this would be like religious affiliation. If you have a survey with religious affiliation, it's a nominal data point, right? Ordinal is where there's a rank order, but it's not equal between the ranks, right? So like where you rank something is not, there's not equal distribution between them, right? Does that make sense? They're not the same amount apart of whatever. A good example of an ordinal would be like, and I know this one's just coming up, but the election's like on my mind, right? So political affiliation is another good example of ordinal. Because you can rank them, right? You could rank parties, and people often talk this way, on the basis of them being liberal or conservative. And we only have 2 parties in the United States, but if we had more parties, you would realize like very quickly that like your party affiliation and how liberal or conservative is not necessarily like an equally distributed thing, right? Like generally there's not very much in terms of conservative politics between you, like sort of like center right Republicans, right? And does anybody know what the most conservative form of government is? Political ideology is? Can you talk about political affiliation? What would be super conservative, do you think?
Fascism?
Fascism, yeah. There's not actually a lot of parties between these two. There's not as many parties between these two as you get between sort of, you know, center-left liberals, right? Where you could have, you know, socialism, you could have the Green Party, you have labor, right? You have communism. So if we were to like ask you guys, and we had a list of political affiliations to choose from, we could or make it an ordinal variable and rank it from liberal to conservative. But the distribution between them ain't the same. Does it make sense? Just because you don't usually have parties in between. So that's an example of ordinal, right? Interval, does anybody remember the example for interval? Height, yeah, height's a good example, right? When we were just doing interval and ratio together, which in the social sciences they almost always do, because they always teach you the difference. That way when you see dash, ratio, you know the difference, but really when it comes to our test, it's generally the same. Yeah, so height, weight, right? Anything where there's like equal distribution, right? So like 1 inch higher is always 1 inch higher than the thing before, right? No matter what height you're at. So it's interval. There's equal, this is how you think of it, there's equal intervals. So nominals are names, ordinals, there's an order, interval, right? Equal interval. There's equal distance between them. Now, our chart, what they're doing is they're essentially getting you to think about the fact that like, what kind of data questions you ask, what kind of data you collect numerically determines what kind of test you would do statistically. Now, the reason why I say this is kind of a false chart is because actually there are now, and there was when this book was written, and I don't know why they aren't on this graph, there's forms of regression for every single combination, and that's generally what people do. So if you're doing nominal, you might use something like nominal logistic regression, right? If you're using ordinal, you might use ordinal logistic regression. But there's ones that are that's for if you're using interval and nominal data together, or if you're using ordinal and interval data together. But there's other tests that you do for nominal and ordinal and nominal, right? Does that make sense? I'm not going to teach you guys all the different variants of regression, but just be aware that when you're thinking about research, right, inevitably, what kind of questions you ask is going to set the limitations on what kind of mathematics you can do later on if you're doing statistical research. Which is why sometimes on questionnaires you get kind of wonky questions, because people might try to take something that's ordinal and ram it into something that's interval so that they can do the testing, right? So like, if you wanted, rather than talk how you normally talk, like, does anybody think about how you would reform this to make it interval? You could. If rather than being like, what is your party affiliation, choose from the list, if I was like, in a scale from 1 to 10, how much would you consider yourself liberal? From not very liberal to very liberal. What have I done? I've taken an ordinal level variable, transformed it into an interval level variable so that I can do different forms of statistics on it, right? So in a lot of ways, and I'm not going to expect this level of specificity when you write your own surveys, right? But if you were doing it professionally, you would have to think about each of these questions. What level of data there was, what test you wanted to do, and so basically transforming the questions so that they would work together. Because it's going to be harder, or at least it's not going to be as strong mathematically, or you're not going to be able to do the kind of analysis you want to do if you have certain variables over others, right? Make sense? Of course, there are fixes to everything. So getting back to like, multiple linear regression is the best, right? It's better than using nominal linguistic regression in a lot of ways. You can use nominal linguistic regression though, right? A lot of times the reason why people want to control which tests they're doing is some of them are easier and less time consuming and involve less tests to check and make sure. Because there's also like post-testing. Is anybody aware of this? Eventually, if you go on in statistics, you're not only going to learn the tests that you learn in. So this chart probably involves the ones you would learn in statistics. So that's why I think in an undergrad text it is the way it is, right? Because like you're very likely to learn at least some of these. Chi-square, you're very likely to learn chi-square, right? You're very likely to learn t-testing and ANOVA at an undergrad level. You're less likely to use those as a researcher, but you're very likely to learn those, right? And when you're actually doing research, it's more just flat out regression, and then various forms of post-testing where you make sure that what you're looking at is actually accurate. Okay. Any questions about how you analyze numerical data? I know that was like a forced march to the end. Cool, wonderful. That will be it for today. So tomorrow, or not tomorrow, Thursday, I will be here. Come in, especially if you're confused about your research design, especially if you don't know which research you're going to select, why you're going to select it, questions like that, right? We have to make sure that by next week, you guys are at the point where you've moved from talking about it as a concept, like it's a term paper that you're doing for another class, to how am I going to actively research it in a way that's methodologically sound, right? If you need help getting there, come to me. Thursday, class period, here.